Thank you to ITWC for hosting this event and inviting me to speak today. My name is Yogi Schulz. In this presentation, I'll describe common data visualization bloopers and their solutions. You can easily adopt these solutions to impress the audiences that you present to. Who am I? I founded Corvell Consulting over 20 years ago. We offer information technology consulting related management consulting work. I write a regular column at IT World Canada that's targeted at CIOs and IT managers. So let's talk about data visualizations. Cluttered versus minimalist data visualizations. You can see this, how confusing this chart is. We've all sat through unreadable, confusing, boring, or even misleading presentations with their associated data visualizations. The latest example is data visualizations about the COVID-19 pandemic. Here's a humorous chart that's a sarcastic reaction to many of the unintelligible COVID-19 data visualizations. Poor or mediocre data visualizations are caused by a lack of thoughtfulness about how best to present the data in a chart that will resonate with our audiences. Sometimes the problem is that the author of the data visualization is using a chart to deliberately mislead the audience. That's unfortunate. In this presentation, I'll show examples of the worst offending data visualizations. For each example, I'll describe how to make the data visualization more powerful so that it will communicate your message better. Overall, we should avoid cluttered charts and aim for a minimalist approach. Less is more is a phrase adopted in 1947 by the architect Ludwig Mies van der Rohe. This statement applies big time to data visualizations. We must avoid confusing clutter at all times. So in this cartoon, we see him say, he's right. When you look at the chart this way, it's not so bad. Be positive about the data you're presenting, but not misleading. Okay, here's the first one. Bad design versus good design. The two data visualizations display exactly the same data. The bad design chart that you see suffers from several problems, including annotating every data point with its value. The annotations overwhelm the chart and hide its message. The y-axis label is an abbreviation that's not easily understood. The y-axis does not start at 0. The x-axis numbers suggest an increasing range of value, but are in fact the number of a month. The year associated with the months is not shown. The legend and the time series symbols are too far out of the way visually. So here's the good design of the same data. It's more visually appealing and avoids these problems by formatting the 3 time series to stand out prominently and avoid a legend, replacing all the data point annotations with a table of value. Now the values are still available, but they don't detract from this chart. Spelling out the y-axis label, starting the y-axis at 0, labeling the x-axis with month abbreviations, showing the year associated with the data. A well-designed data visualization focuses on displaying the data, but it's never busy. Here we have an example of an unclear pie chart versus a clear bar chart. Avoid creating pie charts like this one on the left. We humans can't easily estimate the relative size of the areas of the slices. Those size estimates are almost always required to understand the message of the pie chart. Your message will be much more easily understood by your audience by another data visualization type, such as a line chart or a horizontal bar chart, like this one on the right. A horizontal bar chart shows the lengths of the bars, and they communicate the values instantly. By labeling the individual bars, we avoid a legend. A legend requires your audience to look back and forth between the legend and the chart while remembering a specific color. That tedious effort is also prone to error of understanding of what's going on. Now here we have a situation where we have a choice between a confusing message and a strong message. The Siamese chart that I'm showing here brings together multiple time series, various line types, multiple data points. The manually drawn blue lines and the text boxes turn everything into a visually confusing mess that will only annoy your audience. There's a low limit to the amount of data your audience can absorb at one time. This chart far exceeds that upper limit. Now, here's a similar chart that illustrates the upper limit of the number of time series that a line chart can contain and still be an effective communication vehicle. Notice how sleek and straightforward this chart is. Now we have coincidental correlation versus strong causation. Correlation between arcade revenue and computer science doctorates is a totally coincidental correlation. If this correlation were accurate, a candidate with a computer science doctorate could improve their likelihood of being awarded the degree by spending more time playing arcade games. We know this is nonsense. We need to be extremely skeptical of correlations because coincidental correlations occur frequently during statistical analysis of every type of data. How then do we differentiate a coincidental correlation from a legitimate correlation? Well, legitimate correlations are explained through a plausible analytic story that describes a strong relationship between the two time series. There's no plausible story that can relate the two time series in the previous chart. However, in this second chart, you can tell a plausible story about how interest rates and inflation rates are related. That's an example of strong causation. Multiple y-axes versus very few y-axes. Some charts use two or even more y-axes so that the data points for multiple variables can be displayed on one data visualization. Before applying this chart type, you have to ask yourself, is there really a relationship among the variables I want to show on one data visualization? If the answer is yes, then this chart type can enhance your presentation. If the answer is no, which is often the case, then you're likely using this chart type for one of the more following dysfunctional reasons. First, you're trying to reduce the number of slides or the space being used. There's no value in that approach. Second, you're deliberately trying to mislead your audience by claiming a relationship where there isn't one. That's unethical. In either case, you will create confusion for your audience. That's never good. The more y-axes you want to use, the more you should ask yourself if you should be using multiple clearer data visualizations rather than a jam-packed one. A better alternative is to show multiple data visualizations side by side or successive slides. This chart on the right illustrates an effective use of multiple y-axes. There's one y-axis on each side of the chart. The color of each y-axis is identical to the color of the associated data. Using a histogram for one time series and a line for the other is an excellent contrast technique that also avoids clutter and improves communication. Now, what about a misleading truncated y-axis versus a full y-axis? Truncating the y-axis by starting at a value greater than 0 accentuates the differences among your data values. It's usually employed to mislead the audience, as in this example chart. Charts should show a baseline of 0. When you look at a chart, try to confirm that's the case. Often, a data visualization designer resorts to truncating the y-axis because he or she has realized that the more accurate chart won't be meaningful to the audience and doesn't support the recommendation. Those are very poor reasons for this chart type. So a best solution to a truncated y-axis is typically one or more of the following actions. Show the accurate representation of the data and then zoom in on the part of the chart that supports your point. Abandon the ineffective chart. Use another chart type for your data and perhaps use different data from your analysis. And thirdly, sometimes we just have to grin and bear it and accept that the data doesn't support your recommendation. Continue your analysis, identify a new and supportable recommendation. Now, here's an example of errors in arithmetic versus accurate arithmetic. The slices of a pie chart must always equal 100%. Now, perhaps this chart designer was consuming too much of the product when he or she designed this chart. This pie chart is an example of using the wrong chart type to represent your data. The 3 data points are all associated with specific years. A better chart type for this time series is 3 vertical histograms. Always check your data visualization for arithmetic problems before you publish it. Identifying a small problem may lead to further design thinking that will improve your chart effectiveness. So now we have no motion versus motion. The chart on the left is basic and boring. Incorporating motion into the data visualization is an excellent way to present time series data. Whenever you can add motion to your data, you will convey your message more effectively. Presenting trends in your data is always more powerful than showing only point-in-time data. So those are the points I wanted to discuss today. So here's what I want you to do. Avoid these chart Bloopers. Replace a cluttered design with a minimalist design. Avoid bar charts. In many cases, a bar chart or a line chart is better. Simplify a confusing message to produce a stronger message. Don't let coincidental correlations fool you. Look for strong causation. Don't show a truncated y-axis. Always show a full y-axis. And upgrade no motion charts to a motion chart whenever that's feasible. Well, I hope you found these ideas useful. If you look at the downloads, you'll see a sheet there that contains these points and many more that you can use to help you improve the visualizations that you're working with. We invite you to register for these two webinars that I'll be giving in a few weeks to explore data analytics and the related data visualization topics in more detail. Please register using the webinar description document that's also found on the download page, and it contains a 50% discount coupon, and you can click on the link there.